We're going to kick off by introducing Randy Zhang, who will be presenting on using AI agents for automated networking script development. Randy is a principal architect at Cisco Systems, and he has traveled from Washington, D.C. to be with us today. This is Randy's third time presenting at NANOG. His first talk was at NANOG 55 in Vancouver in 2012, when he presented on deploy packet transport with MPLS-TP. Randy, welcome.
It's always tough right after lunch, so I hope you guys stay awake, and I'm going to try my best to keep you guys awake. Welcome, everybody. Today's session that we're going to focus on is using AI agents to automate network script development. You heard quite a bit about the capabilities of a generative AI, and we're going to specific today to zero in on one application of Gen AI for networking script development. We're going to start the introduction how the script development is really related to AI. Then we're going to look at how agentic AI in particular be used for this purpose. Then we're going to explain what agent is, what agentic AI is, and how it relates to the script development. Then we're going to look at how to use generative AI to build some type of a script development automation framework, followed by an example walkthrough in detail how you would develop such a framework for your script development projects. We're going to use the Microsoft Autogen as the example for this purpose. How can we leverage the generative AI for networking script development, right? That is the topic today. And if you look at a typical networking script development lifecycle, you may, depends on the type of a project and the complexity of the project, you may start looking at this from the perspective doing the planning, define what the problem is that you're trying to solve, what kind of requirements that you have for that script. Then you may prepare some devices to validate your script. Then, of course, the main part of it is the script development, writing the script, followed by some kind of a testing of the script, making sure the script works as intended. Then, as always, not every time a script is written, it's going to work the first time, so you may run into bug fixes and feature enhancement, more stability, robustness enhancement, all those things that you normally do with the script development. Then perhaps you may looking at documenting the script so that future enhancement, future releases, you can leverage that documentation for easier enhancement. Then that cycle may continue, multiple iterations, again, depending on the complexity and the size of the script. And what are changing also, let's look at some of these new requirements and why there's a need for accelerated development. First is frequent change in requirements. How often do you see that happen? I would say pretty often. You have some requirement today, maybe in a few days, that requirement has shifted. You have either additional requirement or you need to take out some of the requirements. The requirement is slightly different or maybe very different, so you have to adapt your development for that new requirement. Next part is automated testing. You would like, if you have a script, you would like to have more automated testing so that the script can be validated either through the live equipment or through some kind of environment that helps you validate that script is actually working in your environment. Then the next part is kind of interesting. There's this new paradigm with the introduction of generative AI, there's this new conversation about disposable code. How many of you have heard about that disposable code? And when we talk about software development, we always wanted to say that your code is reusable, right? Your code is reusable again and again so that you write once, deploy as many times as you want. And that is a very common requirement. You want the code to be reusable again and again and again. But given the rise of a generative AI, there's this concept of a disposable code. By disposable, the code is written, used one time or a couple times. It's not reusable. It's not intended for reuse. Why? We're going to go through some of the reasons later, but the main reason is that you can create on-demand scripting. You don't need to have reusable code anymore. So the code becomes not reusable for the purpose of development, but it's more for disposable, come and go. The value of the code diminishes with the reusable code, but you get much faster introduction of the code because you're not thinking longer term, you're only thinking about short term, right? And what it goes with it is there's less maintenance of the code. With the reusable code, you need to think a lot about how to maintain that code for the future, right? With disposable code, you're only thinking about right now. Does the code solve my problem right now, right? Not thinking about the longer term, whether that code is going to fit into the big picture, whether it's going to work for some other environment, whether I need to enhance it, right? That's the new paradigm that's being introduced. I'm not saying this is a big trend yet, but there's a lot of conversation in the AI community. So how can agent-based or agentic AI going to help us answer some of these questions? We're trying to go through some of these questions later. So for networking script development, right? What are the things that we can ask AI to help us? There may be a lot of different questions or demands that we can put on the AI. At least there's some of the demands, some of the questions. We're going to ask AI to understand my networking requirement. The keyword is my networking requirement. And convert them into an action, some kind of action for that requirement and convert it into code, right? That's what we're really trying to do. Second is write code based on that plan. Once you have a plan, you want to make sure AI writes out the code. Not me, not us, not humans. AI does the heavy duty, writing that code out. Then we also want AI, hey, by the way, once you write the code, review the code, make sure it works, right? And test the code. Then we say, okay, AI, good job so far, but I want you to actually execute the code. Can you do that? Not just writing the code, I want you to execute the code, run the code in my environment. Then, by the way, fix any errors that you're running into. You create the code, you fix the code, right? We're asking a lot, right? Then we say, okay, tell me what you have done, everything. Tell me everything that you have done. Then, with the networking specifically, if we have equipment, we say, okay, good job. You written the code, you tested the code, you validated the code, but now I want you to validate the code in my real equipment so that I know your code works. I don't need to validate myself. That allows us to build trust, right? If it is validated in the equipment, we know it works. A lot of demands for AI. Can it do it? Let's see. Now let's take a step back to talk a little bit about what is agentic AI and look at some of the definitions just so that we're on the same page and how it can be used for networking script development. What is agentic AI? Agentic AI is some type of AI system that is designed to autonomously pursue complex, another keyword I didn't highlight, but it's complex goals, and has some type of workflows that can run or execute autonomously. I highlighted autonomously workflow kind of together, that with the limited or no human interventions. So we want AI to take over some of that work, at least majority of that work for us. And that's why I sometimes call it autonomous AI. We're going to talk through some of this concept right here. A key part of the agentic AI is agents. We heard quite a bit about agents these days, right? And AI agent is one of the most searched items on the internet. And it's the top trend for AI development in 2025. What is agent? Agent is autonomous worker unit that does something that we define. And it can make decisions independently with limited or without human intervention at all. Agent can perform one or more tasks, again, independently. The other piece that's important is that agents can collaborate. They can work together like humans do as a team. So they form what we call agency, or some kind of a crew working together solve complex problems. Agents have workflow that we talked about. And the workflow can iterate continuously to solve complex problems, fix issues. We'll look through some of these issues that they're solving. Specifically, let's talk about some of the functions. The first function that agents can do is planning. By planning, agents can take a problem, break it up, and outline what some of the actions that need to be taken to solve that problem that humans push upon the AI agents. And second part is reflection. By reflection, AI agents can review the work they perform themselves and critique themselves. They say, oh, I did this, looks good or looks bad. Here's a problem, I need to resolve it. Here's the good part, I don't need to do it. It's a good job. Pat themselves on the back, so to speak, right? So the reflection is trying to review the work that we humans do that all the time. Third piece is what we call the tool use. By tool is some kind of software function that agents can leverage to perform very specific purposes, such as reading a file from your local machine, collecting data from your routers, and analyzing the data from a database. These are what we call the tool use. These tool use kind of expand dramatically the capabilities of the large language models that they don't normally have access to your private or local or proprietary data. The tool use is the one that expands the capabilities of AI agents. Last but not least, the collaboration that we talked about quite a bit is the delegating work from one agent to the next agent. So the agent may say, okay, this is task, this is not something I want to do or I can do. This task is better for some other agent. So they push that task into another agent, and the other agent picks up that task and performing that task, right? They're working collaboratively, collectively together, solving complex issues. Let's maybe step back. Why do we need agents? because there are some limitations of the foundational AI models. I would have a big caveat there because, as you know, AI model development is changing very fast, right? Daily, I could say, or maybe weekly, very fast. And some of these newer models, what we call the reasoning models, have a lot of these capabilities that are available from agents. They are inbuilt inside the foundational models, and such as the GPT O1, O3, right? They just released O3 Mini a couple of days ago. So some of these capabilities are like reasoning capabilities are already available from the foundation models that kind of enhance further the capabilities of AI agents, which are built on top of the AI models. But in any case, with that caveat out of the way, let's look at why we need agents. And most foundational models, with that caveat aside, their knowledge is static, right? When they perform the training, that's a freeze of the knowledge. It's static and stale knowledge. And most of the foundation models are designed for question and answers, interaction with the humans. It's a human-machine interactions. And if you work with the AI models with like ChatGPT, you know, requires a lot of back and forth prompting, right? Even if you do one-shot prompting, chain of thought, and all these different fancy techniques, AI agents need a lot of attention, need a lot of your coaching and interaction with the agents and with the models. Let's just summarize the key differences between the two, right? The autonomous AI applications, which are agentic AI or agents that we're talking about today, is goal-based. We talked about that. Goal-based instruction with little or no human interventions and can make decisions. And the key part is taking actions autonomously. What we really want is AI to take some actions on our behalf, right? Then we can outsource some of the actions to the AI agents that we don't have to do ourselves. We're not ready to outsource everything to the AI agents yet. Someday maybe most of the actions could be outsourced, but we're not there. But we're slowly outsourcing some of the actions that humans make today to the AI agents. And I will show you later, and they can do some of the work that we are doing today. And in comparison, for the traditional models, the foundational models, for this comparison, they are designed for human consumption, right? Human-machine interaction requires careful prompting, careful context. Even with the RAG, retrieve augmented generation, you are providing additional context that has to be provided to the models, right? And RAG can also be used with the AI agent as well, just another addition to that one. When it comes back to the networking script development, let's just summarize what it is. For the agentic AI is multi-agent framework. Typically it's a multi-agent, not just one agent, multiple agents working together, divide and conquer a complex software development project. They use iterations to improve the quality of the code that it generates. It can perform automated testing, validation with networking equipment. We talked all about that. And the last part is you heard quite a bit with the DeepSeek R1 series of models. You can use a mixture of models or a mixture of experts to do different tasks based on their strengths and weaknesses. All these are available to the agents as well. Here's an example that we can ask Agentic AI take on for us. For example, you say, okay, agents, you lead a team to collaborate on a Python networking script development project. Final completed Python script needs to perform these 3 specific tasks. Number 1, collect device level router configurations for BGP and loopback interfaces, and compare that configuration to a BGP best practices guideline. Then summarize the compliance of these devices and make recommendations if they do not comply, right? This is an example that agent can take entire 3 steps into 1 script. Here's a sample example. Because of the framework that's being available today, it is quite easy for most people, for network engineers, to start the journey today. Here's a very simple example. You can see I'm defining an agent called Planner. Planner agent, the message is, okay, you're a software architect, you generate clear, detailed coding instructions for requirements for the coder, which is another agent. You can generate low-level logic to help coder, but you do not write the code. This is the instruction that we can create for the agents to take. And then we connect that agent into a large language model. Now that I talked about the agent, we understand what agent is, what the agentic AI can do, how it can be used for networking script development. Let's look at next step is how can we build a development framework to take advantage of the capabilities from the AI agents. I break it into 3 high-level steps. First steps, you need to understand what you're trying to solve, what kind of problem you're trying to solve, right? Second step is obviously you need to set up the environment and to run through to develop this agents. Then last step is to execute, test drive, and improve upon that script that's been developed. Describe the problem. What kind of problem you're trying to solve? Essentially, what kind of requirements? If the problem is very complex, you may think about breaking apart so that it's easier for the AI to understand, to solve individually. You may create high-level plan, and you may also capture the key requirements. Here are the requirements I want you to satisfy for the script that you are developing. I have an example here with 6 main agents with 1 user proxy agent. Let's talk through what these agents may do. Here are what we tell the agents to be, their role. The planner agent can kick off the project with a detailed project plan and the role assignment for all the other agents. That's the purpose of the planner agent. The coder agent is the main agent that writes the code, right? It writes the code based on the requirements that's provided by the planner agent. Planner agent essentially takes all the requirements, convert it into a plan or some kind of outline what needs to be done, and the coder agent takes that requirements from the planner and starts writing the code, constructing the code for that requirements that we set up. Then the critic agent is another agent that reviews the code that's generated by the coder agent and enhances the code, checks for errors, checks for, typically you would see checks for security, robustness, logging, a lot of these capabilities that the review agent is going to perform based on the code that's written by the code agent. And you may have a unit test agent. Unit test agent is essentially unit test the code. First write the unit test code, then run the unit test code to find out if that unit that's written are functioning. Different parts of the code written by the code agent, are they actually working, right? The unit testing is going to perform the unit test and making sure all the units pass. Then another agent, a system agent, is looking at holistically entire script putting together. Is it going to work? So it looks at the system level. The unit testers look at individual unit tests, right? The system agent is looking at the entire script. Then the reporter agent is going to look at what's being done. Do I need to document the code? Do I need to check for anything that's missing? And write a report about the work that's been done. And then the last, the user proxy agent is interact with us and executing the script that's written. As you can see, there are several agents. It's up to us, humans, to define how many of those agents, what they do, what kind of detailed tasks they are going to perform. It's up to us. Once we define it, the agent is going to take over, start their workflow, and we'll see a little later. Now that we understand the requirement, let's go to the next step is setting up the environment. By setting up the environment, I outline some of the tasks that you're going to have to think about is, okay, what kind of agent development framework and what kind of models that you're going to select, the foundational models. There are several parameters, the cost, context window size, rate limits, performance, hallucination rate, a bunch of other stuff, right? And obviously you need to get the API key because we're going to run through the API. Then what kind of language? Most likely going to be Python these days. Then any device access credentials if you have to access the device to validate your script. Here's an example that we can look using Microsoft Autogen agent framework. Microsoft Autogen is an open source multi-agent conversational framework. Agents use large language models to generate code and exchange messages. They can execute the script that the agents write. And agents can receive and send messages, execute, like I said, and they can specialize in different tasks. Typically, the way they set up is you can have templates. They provide the templates. We're going to go through later. The top level template is called a conversible agent. Conversible agent, you can either take directly from conversible agent, or you can take from the assistant agent, which is more specialized agent that you can use. But you don't have to take the assistant agent. Okay, we understood the problem. We set up the environment. Now it's time to execute and run and improve, right? We need to put all together and fine-tune and making sure it delivers what we asked for from the agent framework. These are the 3 steps that we outlined. Now let's walk through with a real example. I have detailed code posted on the GitHub. Feel free to go there to look up all the detailed messages, because the slide, I cannot cram everything in the slides, but all the details there, the GitHub link is provided in the deck a little bit later. And feel free to take a look at all the detailed messages and the code that's generated. It's pretty straightforward to follow through. Now let's look at an example. This example is a very simple project. What we want the agent framework to do is create a Python script doing these things, 3 things: collect router BGP configuration, compare with the BGP best practices, then summarize the compliance and generate recommendations in a report. Whether it's compliant, not compliant, what is not compliant, what are the recommendations, right? The script needs to do all these 3 things. But the framework, we want to have another step. Second step is we want the agent framework to execute that script that's written. And we're going to have routers locally in our lab that the agents can directly access. We're going to provide them the access so that they can execute the script, making sure it collects the right kind of information that we ask for, the 3 tasks, right? And run through it and generate the report. And by doing that, we are confident that script works. It produces the results that we asked for. And then the script is usable. This is the project description. We are going to use, in this simple project, we're going to use 5 of these agents. We talked about them in the past, a few slides back. The planner agents doing the planning, high level, convert our requirement into a set of steps. The coder agent does the writing of the Python code, satisfying the requirements that were outlined. Then the critics agent is going to review the code, enhance the code, troubleshoot the code, fix the bugs. The reporter agent is going to write up the report and perform the documentation. Then the user proxy is the agent that we users interact with directly. Let's see how it is done. In this simple snippet, you're going to see I'm using GPT-4o and as my model. Also, a backup model is called GPT-4 Turbo. The Turbo model is just a slightly different model, but the experience shows that GPT-4o, for the purpose of scripting, code generation, is much, much, much better than GPT-4 Turbo. And so this few lines just allows us to connect 1 or more OpenAI models, or can be any other models, right? Could be Gemini, could be your locally sourced models, like open source models, Llama 3, 1, could be many other models, right? I'm just using GPT-4 or as an example. This connects our framework into that, into these 2 models. Very simple. Then we configure the models, and here I don't have any specific configurations. There are a lot of defaults there, but if you wish, you can configure some of these parameters, such as the temperature of the model. You can configure if you want to change the temperature. Now, we're setting up the planner agent. Very simple. You've seen this message before. The planner agent is a software architect. We tell the agent, you are a software architect, right? You write very clear instructions, very detailed coding instructions based on our requirements, right? And we also specifically ask planner agent, don't bother writing code yourself. Just focus on generating the requirements. and let somebody else, the code agent, doing that work. And then we connect the planner agent to a large language model. The code agent is the main agent that's writing the code, right? And what we're saying here is that, okay, code agent, you are a software developer, you are a Python software developer, you write code based on the instructions that are generated by somebody else. You don't generate the instructions. You just perform a duty that is assigned to you. If planner agent tells you do this, you do that. Do this, right? Not do that. So you do exactly as told. And also, I want you to fix errors if you have errors. And then we connect to the large language model. The critic agent is very similar to the code agent, but the critic agent's main job is performing reviewing of the code that's written by the coder agent. The coder writes the code and may fix the bugs that are found by the critic agent. But what I've found is that the critic agent may also directly fix the code. And it's not forbidden for you to do because critic agent is a Python code reviewer and critic, right? So the critic agent can also fix code. But the main thing we want the critic agent to do is to review the code, make recommendations to the code. We're going to run a little bit faster. I want to leave time for questions and answers. So we're going to run a little faster now. And then you see the reporter agent focusing on the reporting. And here's putting all this together through a user proxy agent. And I draw attention to the executor. Here's we're going to specify, I want you to execute the code. Here's the directory. And then wrap all the messages together through a group chat and initiate the chat. Once we initiate the chat, entire workflow starts by itself. Here's a snippet of a sample planner agent. Again, in the interest of time, I'm going to run through very quickly. And you have all the details, a lot more details, exact details in the GitHub. So you look at here, step-by-step plan, detailed coding instructions for coder, and next steps for coder, right? Reporter, here's what you need to do. And then here's an example of executing the code block, and you found an error. And here's how it fixes the error. Whenever exit code is 0, the code works, right? It did it by itself. And then here's the reporter. Reporter says, okay, I've done all this work for you. Look at all the details. Here all the files are generated, all the sample configuration files are used, recommendations, conclusions, everything. This is all generated by the reporter agent. So here's the GitHub repo, automated networking script development with AI agent. If you go there, has all the details of the messages that I went through very quickly. And bottom is another project that I did with the hackathon hosted by the US federal government for defense. And two more links for you. One is, the top one is how to use AI agent to automate enterprise level software development. It goes into a lot of details, some of the lessons that we have learned during that development. And last one is slightly off topic than here, but hopefully it will give you, because we're networking folks, it will give you a lot of details. I go into a lot of details what the networking protocols are. And in terms of AI, it talks about the collective communications and InfiniBand, Rocket V2, and Ultra Ethernet. A lot of those topics may be of interest to you. So I put it here in case you are interested. Then quickly summary. So agents may go back and forth. And there may be some common problems One of the common problems for agents is when it comes to Python is the indentation. Indentation, agent has a hard time of creating the right indentation, and you may have different results when you run at different times, different models, and you're going to use a lot of tokens. Keep that in mind. And definitely, the Agentic AI presents very interesting local alternative for software script development, for networking script development. And it's important for you to validate the code. And review this code. And the hardest new programming language is not Python, according to Andreas. All right, and I'm open for questions.
Thanks, Randy. If you could just stay on, I think we have 2 questions from online, and folks in the room, you could just line up by the mic.
Hi, my name is Sergey. I will be reading out the online questions. So first question is from Dan Magurian, and he's asking, how do you consider the AI hallucination, whether this is a big problem for network engineers, because as Dan's perception, the AI could produce, even when the AI produces 10% of garbage, that could be unacceptable for the networks.
Thank you for the question. For sure, any garbage is bad, right? We don't want garbage. That's why one of the main thing I stressed was that you need to validate the code. And in this example, I show you that the AI actually runs the script itself and goes to the actual equipment, collect the results, and the results are exactly what you wanted. But you always be careful. You want to review what's been produced. You don't want garbages, especially for production network.
Do you feel the situation is getting better?
It's getting a lot better. With the newer models, I have not tested with the O1 model because the O1 model is what is called the reasoning model. It's much better in terms of software development. So we're going to expect better and better models.
Thank you. More questions. Your examples are nothing that couldn't be done with expect script with less complexity like 30 years ago. Does it mean that the hidden agenda of AI is to dump trained network engineers with someone with a minimum wage and makes the AI make the whole work?
That's a tough question, right? So I'm sure that they are, but the reality is AI is here. Whether you like it or not, you have to deal with it, right? I'm not saying AI is going to do everything, take away all the jobs. I'm just saying AI is here, and the capabilities are increasing every day. Whether we like it or not, it's better for us to be more open, to embrace it, identify the use cases that we can leverage it, instead of saying, oh, it's taking my job. And yes, some of the jobs will be gone, for sure.
Thank you. Last question online from Saimham. How far are we from a place where network engineers can have agents develop relevant RPC servers or clients and also deploy them to production, let's say, Kubernetes clusters?
I've seen a lot of projects out there that are doing that today. Yes, RPC is one use case, and even doing the SQL lookup, doing all kinds of development, doing at the production level.
Thank you.
Thank you.
I have one quick question. How are you ever going to have it say no? It's always going to say functions as designed, right? No trouble found, because it did the whole design. So how is it ever going to say, oh no, I didn't do what I told myself to do?
In terms of
like your critic and your reporter are part of the whole series of what you told it to do. So it's going to do what it told it to do. But what if what it told it to do wasn't quite right, because that was part of the whole process?
Right. Then you have to look at the outcome, right? That's just the process. At the end of the day, coming outside of the agent, what is that script that you asked for? Does it deliver what you're looking for? If it doesn't, that means something that you gave is either is confusing or inaccurate. You may have to go back to fine-tune some of those requirements.
So it's the person who has to do it, or the AI is going to do that?
Yes. AI right now is not that smart,
Okay.
right?
Okay, I thought you were saying that the AI was going to also determine whether or not this worked. So I just misunderstood.
Someday.
Okay.
Right now, we're saying, here's what I need. The rest of it is, okay, AI, go do it, right?
You could do it quickly.
Yeah, just a quick
last
question.
yeah.
Yeah, so we kind of went through the slide a little quickly. I was just curious on the group chat part of the presentation. How exactly are those agents going to communicate to each other? Is that through prompts, or is that through another form of communication?
There are multiple ways. What I've done, do I have time? I can go back. Oh, it's locked up. And you can have the large language models to do themselves. They can, based on the messages that come in, the agents can decide who's the next agent to pick up that messages. That's the automated workflow. But if you are really more advanced, you can dictate what kind of messages are being transmitted, who's the next, what we call speaker, who's the next speaker on that chat.
Okay.
All right. Thanks so much, Randy. Thanks for the questions. I guess they could find you off stage. Thank you.